This is your lesson on identifying conic sections. It follows the examples in 8.6. I'd like to do a little bit of a PSA. Please make sure you're looking over sections 4 and 5 where the textbook discusses ellipses and hyperbolas. These are two conic sections that you will actually more closely identify and deal with in pre-calculus. However, you need to be able to have the skill of looking at an equation and identifying which type of conic section it actually is. So please skim through those notes just to help you understand these next couple examples. Example 1, I am to write this in standard form and then determine the type of conic section. When writing something in standard form, I like to create my buddy system where I put my x's next to one another. And then if I had more y's, I've also put them next to each other, but I only have a 4y squared. I'm also going to decide to move this constant over by adding him, okay? Now, when I'm trying to put it in standard form, I'm essentially going to complete the square. I will not need to do that for the y because he has no b term, and half of 0 is just going to be 0. So he's going to remain a 4y squared in my next step. But for the x's, I already have an a value of 1, so I'm going to create a system where I add a square onto both sides, and I'm going to complete the square. What you do to one side, you must also do to the other side. So to do that and fill in the square, I'm going to take this negative 6, I'm going to cut him in half, giving me negative 3. And then I'm going to square negative 3 to get me 9. Okay? So on the right-hand side, I have 7 plus 9, getting me 16. And then over here, it's going to create a perfect square trinomial, where always you will get half the b and put them inside your parentheses. Last thing I need to do to put this completely in standard form is I need to get rid of this coefficient in front of my y. So I'm going to divide everything by 4. Okay, and I mean everything. So then, use my little eraser here. 4 divided by 4, that's just going to get me 1, which is just going to leave my y squared term by himself. And 16 divided by 4, that's just going to produce 4. Oops, my eraser's not working here. There we go. So now I have this equation of a conic section, and it's in standard form. Both terms are squares, so I've already eliminated the fact that it's a parabola because we have two things being squared. And it's not going to be a hyperbola because these two squared terms are being added. So it's either going to be a circle or an ellipse, okay? Well, just by looking at the fact that we had an x squared with a coefficient of 1 and a y squared with a coefficient of 4, I can eliminate a circle because they need to have the same coefficients, okay? So this is the ellipse. This is going to be our conic section. Now we're going to take a look at example 2 and just purely look at their equations. Looking at the first one, I'm noticing that I have a y squared as well as a negative 2x squared, eliminating parabola. Notice that the y squared is a positive coefficient and the x squared is a negative. Because one is positive and one is negative, this tells me that my conic section is going to be a hyperbola because I'm the subtraction between two squared terms. All right, and B, notice once again I have two squared terms. Both of the coefficients for my squared term have a coefficient of positive 4. Because they are both the exact same coefficient, that tells me that this is going to produce a circle. The very last problem that I have here, I'm noticing that I only have one squared term, the y. Because only one term is being squared, this tells me that it's going to be a parabola. Now, if I had asked you to go further on this one and tell me more about the parabola, for example, the direction that it opens, all you need to do is isolate the x, okay? Because our y is being squared, we know it's a horizontal parabola. So you could go further if you needed to. All right, once again, please make sure you're looking over those notes for ellipses and hyperbolas to help you better understand the differences between our conic sections.